No, I'm just going to add to it.
Oh, yeah.
Just add to it.
Stephen Murphy, I dare you to work as.
Solve it, it's just.
I don't know what it is, but I dare you to solve it.
Grab it.
For a second, I was like, where's my cookie solve?
Just- I bet you it has an asymptote at 3. Solve the equation of sine value. What theta value has a sine of negative 1/4? Now, here's where it gets to be a little bit easier for you. Because these will not be built off of your triangles. These are going to be built out of your calculator. So what you need to make sure you have with the calculator here is that you are in degree mode. Because they're going to give you parameters here between degrees or radians. So you'll have to be able to differentiate between the two. Usually it's going to be degrees. It's very rare you see it within radians. So what happens now is that if you want to figure out what theta value, what angle has a sine of negative 1/4, what do you put in the calculator?
Inverse sine of 1/4?
Yeah, so you type in the calculator sine inverse of negative 1/4, and it's going to give you some degree measure. What does it give you? Good, you're getting negative 14. Remember, this is where it comes back to what we did yesterday. Yesterday we talked about sine values. Sine values are always calculated between negative pi over 2 to positive pi over 2, between positive 90 to negative 90. And it told you that you have an angle measure here of negative
14.48.
14.48. So that means that, according to my graph, it's down here somewhere. It has a reference of 14.48. Everybody okay with that? The reason I'm saying it has a reference of 14.48 because it's bounced off the x-axis 14.48 degrees. Obviously, if I wanted to find the actual degree measure that's in the real fourth quadrant, it would be in the 300s. Do you agree? But what sine does in your calculator, or like you did yesterday, it's only calculating between the positive 90 to the negative 90. Now what you need to do is move this angle into which quadrant? Third quadrant. Because what happens now is that this 1448 is your reference angle that you need to bounce to the third quadrant. Because don't these two guys have the same y coordinate? That's why the sine values in the third and the fourth quadrant are both negative. So now, how do I find, if I have a reference angle of 14 and change, what will my angle be in that third quadrant?
180 minus 14.
If it was 180 minus, I'd be moving up, wouldn't it?
180 plus.
180 plus, because you have to add your reference angle to drop below that, because you're going to find the angle that is between 180 and 270, and it's right there. So that becomes, what is it, 180 is 1448, 194.48 degrees. What we're doing here is the first part allows you to find the reference angle, and then you just bounce it into some quadrant that it asks you to find. Okay? It's whether you're going to be bounced. Remember, when you're working with quadrants, when you're bouncing reference angles, if you're going to go to the second quadrant, it's 180 minus the reference. To the third quadrant, it's 180 plus your reference. If it's fourth quadrant, it's 360 minus your reference. That's how you found those. That's how we bounced reference angles around before. This is just another way of using it. You're finding another angle that has that same sine value. And you can check your work here easily. If you type in your calculator sine 194.48, I'll be darned. It's pretty close to negative 0.25. That's how you check your work if you did it right. You bounced it correctly. Okay. Yes, sir.
Why can't you have it like a negative degree?
For the answer?
Yeah.
Because the parameter that they're setting is that they want it between 180 and 260.
So if they gave you negative numbers.
Then you can move it to, yeah, then you could do it negatively by moving it around also, okay? That's a good question. I haven't had anybody ask that to me, so AirPod for you. No one's asked that. Okay? She's something. Not so bad? Do you have any idea what's going on, AJ? Math, very good. You're in the right spot. All right. We'll do another one with the sine value. We have the sine of theta is going to equal negative 0.35. And then they're going to want you to move that again to the third quadrant. It just happens to be dumb luck that the questions that we have up here are all, the ones we've done are going to be third quadrant. I have other ones here for you in a second.
Can I ask that someone's asked that question today? You just have to say it.
Yeah.
Are there gonna be any where it's like 180 to 360, or is it just gonna focus on one quadrant?
It'll go to singular quadrant because what I want you to remember, and this is the reason that this works, is the signs, your SIGN, plus plus, minus plus, minus minus, something like that. Remember, it goes cosine sine, so cosine is positive here and here. So if you have a positive cosine value, you can find the two angles that mirror it between these two. If you're looking for the same sine values, you're looking between here and here. If you're looking for negative cosines, you're over here. That's why we bounce back and forth between our different signs, our SIGNs. Does that make sense?
Yeah.
Good. So when you do this, you type your inverse in, we get the inverse sine of negative 0.35, and you get negative 20.49. Good. Remembering that sine values go between first and fourth.
And what was the answer?
Negative 20.49. So if the angle measure is negative 20.49, what's its reference angle?
20.49.
Very good. This wants you to go to which quadrant again? Third quadrant, because sine values are still negative in the third quadrant. So I have to come down here, 20.49. So what's your theta? Well, what's 180 plus 20? Don't use your calculator.
200.19.
What? You use your calculator for 180 plus 20? Well, I wasn't trying to hit you because I wasn't going to hit you in the head. I was just trying to throw it towards you.
Alright, Mr. Murphy, on tests and stuff, I even like use my calculator to like 10 plus 6 or something, just to be sure. Just to not do anything wrong.
That's why it is. Tangent. Tangent theta is 2.4. Yeah, exactly, 2.4 per tangent. So when you set up tangent, you're still doing the same thing.
Why can tangent be greater than 1?
Tangent is opposite over adjacent.
Oh, okay.
Your opposite values could be larger. Like, think of a 3, 4, 5 triangle.
So it can't be less than 0.5 and it can't be greater than 2.5? Because if sine is 1 and negative 1, the 0 would be half, right?
No, because you can still have tangent values. Because the theta value, it doesn't matter on the angle. Because the theta value can give you, because I think there's an example on one of the problems that you find a tangent like 11.8.
Okay.
Because it's just a side ratio. It's just like really big sides divided by small side. All right. Remember, tangent is bound again between positive pi over 2 to negative pi over 2, excluding the verticals, because you can't divide by 0. So when you type in tangent of 2.4, or inverse tangent 2.4, you get first quadrant and what is it, 67 something? 6738, thank you. Now, first quadrant angles, aren't they their own reference? Okay? Now tangent, remember tangent is sine over cosine. So if tangent's positive in the first quadrant, where else is it positive? Third quadrant, because a negative divided by a negative is. So if I want to get over here, I bring down the reference of 6738, and what do you get for this angle? Very good. 247.38. Not bad, is it?
Do we need those in radians?
No, because they're just giving you two straight degrees. When they give you in degrees, you just stay in degrees. It's not going to ask you to go into radians. It might, in order for you to do something like this within radians, you'd have to be given the circle.
Okay.
It'd have to be inverse sine of pi over 4 into between, whatever it works out to be in radians, okay? You'd have to do something like that. So let me show you this. Yeah, but there's some that aren't. Seem like it's going to be too bad. Tangent of 5.3 going into the third quadrant. You start in the first, you add 180, and you wind up there. Question? Easy. Okay. Sine negative 0.89. When you start with the sine value to be negative, you probably drop to the fourth quadrant. It's asking you to go to the fourth quadrant. So what happens here is this becomes your reference angle. Okay? So you find out what the sine value is then within the parameter of 270 to 360, you have to come back around. So you take 360 minus your reference angle, and there's your answer. So if the reference angle was 40, it would be at 320. Okay? Does that make sense?
Yeah.
All right. Cosine. Cosine, remember, it's bouncing between first and second quadrant to get all of your possible values, because positive and negative. As it comes across, you wind up here at 100 and, was it 124, 126? 126.
26.87.
Okay. Now, doesn't 126 and change already wind up within the parameter that's asking for? Yeah. So you're done. What would be different here is if it asked this within the third quadrant, then you'd have to find this reference angle to bounce into here. That's the only thing you have to be cautious of when you're finding a cosine that's obtuse, because then you got to get your reference to become vertical. Okay? And then lastly, the tangent of 1.5, it's asking you for a positive tangent value, which should bump you to the first quadrant. It doesn't that automatically give you your solution that they're looking for? Yep. You're done. Where is all this getting us to?
Wait, when do you need to make the obtuse angle vertical?
Let's say this question, it gave you the obtuse angle to be negative, and it was asking for it in the third quadrant as opposed to the second. Then you'd have to just bounce it down. That's all. You just reflect. It's just better.
Would it be 180 minus, would it be 180 plus 126, or would it?
It would be the reference angle. Remember, the 126 is the theta, the reference is how much is left to get to 180. So it'd be 180 plus the reference here.
Yeah, I get it.
What this is going to allow us to be able to do it over the ideas of bouncing within quadrants and stuff is to do the following. And we're going to find all possible solutions.
Are we actually going to do this problem?
We're going to, it's an example where we're going to go. I'm going to walk you through it. It's relatively easy because what you're looking at here is nothing more than two steps. If I cover up this nasty word of cosine, it says 2x minus 1 equals 0, right?
Yeah.
How do you get x by itself? Okay. And now this is asking you what angle has a cosine of a half.
Inverse cosine.
Okay. What triangle goes 1/2 with cosines? 30. Very good. 30, 60, 90. So it's this 60-degree angle gives me a cosine of 1/2. You okay on that?
Yeah.
Now, if I'm looking at a cosine value to be 1/2, that means I'm at pi over 3. Because when we solve equations, we're going to use just radians. What else is, when we solve equations as well, it's only going to be built out of our two triangles. So that'll be helpful. What other quadrant is cosine positive?
Third?
Well, I haven't said yes to either the second or the third, so where is it going to be? Fourth. Because it's the x values. So you want to be vertical to here. So if my reference angle is pi over 3, down here it's going to be at
Negative pi over 3.
5 pi over 3. So the two solutions within one revolution that gives me the solution, or give me the answer of cosine of x equals 1/2 would be at pi over 3 and 5 pi over 3. Yeah. You're going to mirror yourselves around. Now, what's going to happen is, depending upon the problem, you might get one solution within a revolution, you might get two solutions within a revolution, or it's possible to have 4 solutions within a revolution, depending upon what, sure, depending upon what the question's being asked, okay? It's nothing more than what we've been working on. Find a reference angle, bounce it into the possible quadrants that it works through. Also, you're going to be able to do this again. I think we did this one yesterday.
You didn't say cosine negative 1 root 3 over 2.
All right, so let's do this. Secant.
I just realized that.
We did something like this yesterday too, right? The composite function, where you had to start on the inside and work your way out. Poor AJ.
We're teaming up the notes, so.
I can switch seats. I'm joking. No, she's doing all right.
Yeah.
She's getting good grades.
I am. I'm doing
Her
pretty
future's
solid.
so bright.
So just work
She's
inside.
gotta wear
out.
shades.
Jesus. This one time I took a picture of myself while I was wearing like 7 pairs of sunglasses, and I said, "Picture so bright, I didn't need shades." Like multiple pairs.
It's a great song.
Like I had.
Gotta wear shades, yeah. It is.
Hey,
It's in about,
here's some
no. Yeah, it's in about 3, I believe is the band.
shades.
They were also the band that did Woke Up This Morning, the Sopranos theme song. It's the same band that did that. This was 2 songs. You have no idea what I'm talking about.
So how about
Anyway,
that problem?
how about that problem up there? It's pretty good, isn't it? Oh, yeah. What angle has a sine of root 2 over 2 negative?
45.
It's 45, 45, 90, but it's negative, so that means when I'm looking at my values of sine,
Bottom quadrant.
I'm down here at negative 45.
Yeah.
So when I'm plotting down here at negative 45, my triangle is 1, negative 1, and root 2. Your theta values are always going to be put in by the origin. By it being the negative, that means the y value is negative because it's 4th quadrant. Now this is asking you then, what is the secant of that theta? Secant is the opposite of what trig function? So cosine would be adjacent over hypotenuse. Secant would be a hypotenuse over, what's your hypotenuse? What's your adjacent?
1.
It's just root 2. And it goes from the idea of starting this problem into the correct quadrant that it places itself, using the theta value that you come up with as its angle in here, build a little triangle to find the opposite, to find what else you have to go with. Really, really straightforward. Okay? All right, these problems. Same section, that 13.4, it's the next page. I think it's 790 something or another. 96. Let's just finish those out, okay? All right, let's just finish out those last bit there. We'll go over tomorrow. I've got a little bit of work stuff for us to do tomorrow as far as some of these, those composite functions. We'll do a little bit more work with those. And what else we do? No, we try to stay off of those. It's not usually good for your brains.
Wait, what did you say?
True. Daisy Court's wonderful for allergies. All right.